Alright, welcome to our video on solving equations with variables on both sides. So when you have an equation where you have variables on both sides of the equal sign, we first care about categorizing our terms. So we have variable terms that have a variable or a letter in the term, and we have constant terms, which will not have a letter attached to them. So when I first categorize these, I see that 4D and 5D are our variable terms, and 8 is our constant term. When you solve for an equation, you try to have your variable terms on one side of the equal sign and your constant terms on the other side. So in order to do that, my goal here is to look at this equal sign and almost cut it in half. So you know where you need to start when you notice that you have one side of the equal sign that has a variable term and a constant term on the same side. So I want to get rid of this variable term because it should be over here. So to do that, I'm going to actually subtract 4D from both sides. So I subtract 4D from both sides. This leaves me with 8 equals, and then 5 minus 4 gives me 1D, which we can also just write as D. So notice here that we have our constant term on one side, we have our variable term on the other side, and we solved for D, which means that this 8 equals D should be your answer. Looking at this problem, we have 8a equals 5a plus 21. So we have our variable terms of 8a and 5a, and our constant term of positive 21. So when we look at this, we see we need to get this 5a on this side with the other variable term. So to do that, I'm going to subtract 5a from both sides. 8 minus 5 gives us 3a, which equals 21. From here, we can identify that once again, we have a constant term and a variable term, and they're both now on opposite sides. So this is roughly where we want to be, except now we want to solve just for a, just like how we typically solve for just the variable. So now you can treat it more like a one-step equation. We divide both sides by 3, and we find that a equals what 21 divided by 3 is, which is 7. And that's our answer. All right, so this one looks a little bit trickier, and there's a reason why. We have a variable term right here, a variable term right here, but we also have two constant terms on both sides. So either way, you can still choose which variable term you want to subtract in this case. I personally am just choosing to subtract 4n from both sides. It doesn't matter which one you subtract as long as we get our constants on one side and our variables on the other side. So I'm going to subtract 4n from both sides. 6n minus 4n gives me 2n. We drag this minus 1 down, equals, and then we drag this minus 5 down. Sorry, almost lost that. Then we drag this minus 5 down. All right, so as we recategorize, we see we have this minus 1 and this minus 5, but now at least we only have one more variable term. So now we're back in a position where if we have two different types of terms on the same side, we have to move the blue color over here so that they're on opposite sides. So to get rid of this -1, I'm going to add 1 to both sides. This gives me 2n equals -4. And now we can just solve it for n just like a typical one-step equation by dividing by 2 on both sides. Then we have n equals -4 divided by 2, which is -2. So n equals -2 should be your answer. I'm going to do one more practice problem here. We have 3x minus 7 equals 8x plus 23. So once again, we're just going to label our terms. Our variable terms are 3x and 8x, and our constant terms are -7 and plus 23. So once again, I'm personally just going to choose to subtract 3x from 8x. It's just my choice. So I'm left with -7 or -7 equals 5x plus 23. Once again, I'm just going to try to recategorize so we can see what we're doing here. So now I want all of my blue or constant terms to be on the left side. So to get that done, I'm going to subtract 23 from both sides. -7 minus 23 is -30, which equals 5x. Then we divide by 5 on both sides, just like a one-step equation, and we see that x equals -6. And this should be your answer. We do have some word problems at the end, but I'm going to save those for a different video. If you have any questions or need any help on your notes, just let me know. Thank you for watching.